Decimal grids and fractions. In the picture below, the large 10 by 10 grid is a unit and has 100 small squares. So this represents our unit, or 1, and there's 10 squares this way and 10 squares that way, so that totals 100 small squares. So each single square is 1/100th, and if you look at an entire column, that would be 10 out of 100, or 1/10 of the whole square. So the first question says, write the quantity represented by the shaded portion of the grid as a simplified fraction. Okay, so we could think of this as each one of these is a tenth, and we have 6/10 in total. But let's try to see it in another way by using patterns. So notice one pattern you can see here, and this is intentionally done this way, is that for every 5 rows, 3 are shaded. So 3 are shaded here out of 5, and the same pattern holds here. There's 3 out of 5 shaded. 3 out of 5. Okay. So even though we could see this as a decimal, it's also the fraction 3/5. Now we're asked to write the quantity represented by the shaded portion of the grid as a fraction with a denominator of 10. Okay. So there's a few ways we can do this, but let's say 3/5 is some number over 10. Now to multiply 5 by a number and get 10, we'd multiply by 2. Whatever we do to the top and the bottom, we also do to the bottom. So we have 6/10. Okay, and we like having denominators of 10 or 100 or powers of 10 because that's what our decimal system is based on. So then we could say that the quantity represented by the shaded portion of the grid as a decimal is 6/10, which we write as 0.6, 0 in the ones place, a decimal point, 6 in the tenths place. Let's look at the next one. So here we have another grid, but it's shaded differently. And we want to do the same idea, write the quantity represented by the shaded portion of the grid as a simplified fraction. So looking at the pattern, we see it's 1 orange strip and then 3 yellow squares, and that's repeated 1, 2, 3, 4, 5 times. So here, we'll label the one over here. Okay. There are a total of 13 shaded out of, well, 2 columns is 20 squares. Okay, and since that same pattern occurs in the entire decimal grid, this has 13 out of 20, or 13/20ths shaded. Okay. Now, what if we wanted to write this as a fraction with a denominator of 100? Okay, so we could count all of these. It would be 10, 20, 30, 40, 50, 53, 56, 59, 62, 65. Okay, so it'd be 65 out of 100, but let's also use our knowledge of writing equivalent fractions. So we want to multiply the top and the bottom by something. Sorry, let's get rid of that. And to get from 20 to 100, we multiply 20 by 5. If we do the same to the top, we get 65. So there's our 65 out of 100. Okay. And notice there's 5 copies of this 13 here, and that's what we ended up multiplying by to get 100. Now to write this as a decimal, 65/100ths is 0, that's 6/10, and 5/100ths, or we can just read this as 65/100ths. Let's look at the next one. Okay, in this problem, we're given a grid, but we're asked right away to write it as a decimal as opposed to a fraction. Okay, so notice there's not a repeating pattern here, so we're not going to use the same idea as the last ones, but we're going to see that each orange strip represents 1/10, so there's 3/10 here, and there's 1, 2, 3, 4, 5. Let's just label these 100ths. So to write this directly as a decimal, we'd have 0 in the whole number place, decimal, 3 orange strips is 3/10, and 5 yellow squares is 5/100. So 35/100. Okay. Now we're going to go in the other direction, and our goal is to write it as a fraction. So to write this as a fraction with a denominator of 100, we know this reads as 35/100. So we can write that as 35/100. That's the equivalent fractional form with a denominator that's a power of 10. Now if we want to get a simplified version, we will have to simplify this fraction. Now the good news when you have denominators of 10 that are powers of 10, remember 10 is 2 times 5. Okay, and 100 would actually be 2 factors of 2 and 2 factors of 5 as a prime factorization. So the only factors you need to see if you can cancel out or simplify are 2 and 5. So I look at 35. Does it have any factors of 2 or 5? Well, it's not even, but it does end in a 5. So I'm going to divide both the top and the bottom by 5. 35 divided by 5 is 7, and 100 divided by 5 is 20. Okay. So this decimal is equivalent as a fraction to 7/20. If we wanted to, we could have drawn this as for every 2 columns, we could have shaded 7, and that would have been equivalent. The shading would have looked differently, but it would be the same area shaded.